Hello everybody! The purpose of this video is to talk about vector word problems and how we can use vectors in real life to solve problems. So, for example, what we're doing here is we're taking a vector like you see from this airplane, it's going this direction, and we're going to add something else, whether it's wind or it could be a boat with a river current. And so when we add those two vectors, we get this kind of vector. And that's the result of adding two vectors, so we often call that one the resultant vector. And if it's in a problem dealing with velocity, we talk maybe about resultant velocity is our answer. But that's overall the goal. You take one vector, add another vector to it, and what's your result or resultant vector? Now, as you see in this example, the plane is flying south, and the wind is also going south. So it's going to push it and give it a stronger velocity. That's great. On the next example, it's flying south, but it hits a headwind that's actually pushing north, so it's actually going to slow it down. So you notice that the magnitude of its resultant vector is a little bit shorter than its initial vector because the wind pushed it back. But again, all I'm doing is I'm taking the first vector, I'm adding the second vector, and this is my resultant vector. Another way that the wind could blow is if the plane is flying this direction and maybe he hits a crosswind. If he hits a crosswind, you can see he's not going to be flying directly south anymore. He'll have a little bit off of the diagonal kind of direction. But again, the steps will always be the same. We'll take one vector, we'll add the other vector, and our answer will be here, the resultant vector. And you'll always have both a magnitude, a length, and a direction. So this first one comes from page 61 in our book. If you want to write this one down, we can just write down that it comes from our book. So, first of all, I'll give you a couple tips on the bottom. Because it's a word problem, it's always sort of scary. So I say the first thing to do is just take a breath. It's gonna be okay, I promise. And then just read it over one more time carefully to make sure you covered everything you read. And then every time something moves, we're going to turn every movement, whether it's the plane and the air, or it's a boat and then the water, we're going to turn everything into a vector in component form. So why don't we do that much so far, guys, and we'll come back to the rest of the notes. So let's look at example 6. Here's what's going on. You have a boat that's traveling 25 miles per hour due east. If the river is moving 10 miles per hour due north, what is the resultant velocity? Which means I'm going to be adding the two vectors. And when I want the result, I want two different things. I want both the magnitude, how long is it, and I want the direction, which way is it facing, of the boat. So what we're going to do is we're going to read it again, and every movement gets a vector. So the first thing that has a movement is the boat. The boat is traveling 25 miles per hour due east. All right. So we're going to put that into component form. Notice what it gives you. It gives you a speed here, which our speed can be our magnitude. Magnitude is often velocity, or magnitude could be actual distance, but that's going to be your magnitude. And then we're given a direction, due east. Now to think about, if we talk about our normal unit circle, what degree is due east? Okay, so why don't we take the boat and turn the boat into an actual vector. So here's our boat. Now remember, if you're given a magnitude and a direction, we have a brand new way of writing this in component form using trig. Remember, it was magnitude times the cosine of the direction angle, and it's going east. Remember, if you're talking about east, east is this way, which is 0 degrees. And we are in degrees for all these problems. So magnitude times the cosine of 0 degrees, comma, magnitude times the sine of 0 degrees. And that's our component form. And we can put that into the calculator right now, or we do it later. Cosine of 0 and sine of 0 is pretty easy, so I can actually do that right now. I know that the cosine of 0 is 1, so 1 times 25 is, and the sine of 0 is 0, so 25 times 0 is. So there's my boat as a vector. So take every movement and turn it into a vector. So there's your boat, and there's your vector. So now let's move on. The next thing that has a movement is the river. So can you turn the river using its magnitude and direction into a vector? Let's try that. Can you figure out what is the magnitude of the river? Meaning, what is its speed? Did you find it? There it is. So our component form should be 10 cosine. Well, what's the angle? They said that the river is moving north. And thinking about north, how many degrees is north? There it is. So we'll do magnitude cosine of the angle direction, comma, magnitude sine of the direction angle. And again, because this is 90 degrees, this is pretty easy to do without a calculator, just using a unit circle. The cosine of 90 is 0, so 10 times 0. And then the sine of 90 is 1, so 10 times 1. All right. So first, two things are good. We found the movement, turned them all into vectors, check, and we put them in a component form. Now what we have to do is, you saw in the airplane pictures in the previous page, we're going to be adding them. When you add the vector of the boat and the vector of the river, what happens to the boat after it's been pushed by the river? So let's find the resultant, the answer vector, by literally adding them. And when you add them, remember we just add the components. So just like we did in previous problems when we learned about the operations of vectors, you can just add the x's and add the y's. Let's do that. So I'm going to take this vector here, the boat vector, and let's add the river vector. And when I do that, I get, let's see, just add the x's, 25 plus 0, and I add the y's, 0 plus 10. Good. That's the resultant vector, and that's great. That's the new vector that the boat is traveling. But we're not done. We still have two more things we need to find. We need to find the magnitude, and we need to find the direction. But we know how to do that. That was on previous work modules. So let me go back to my notes. When you're done with that, find the direction using our formula. Remember this one. And then find the magnitude. Remembering this one, Pythag for mag. Let's do it. All right, so there's my resultant vector, 25, 10. If we do the magnitude, that's Pythag. And because we're in real life examples, we can go ahead and use decimals here. It's a little easier to use than radicals. So I'm going to put this into my Pythagorean, and my magnitude of this vector, notice I use the absolute value symbols for that, because that's magnitude for vectors. It's the square root of 25 squared plus 10 squared. All right, again, radicals are fine, but it's probably better just to go ahead and put it as a decimal. So I'll plug that into my calculator now. Basically the square root of 725, which turns into about 26.9. Well, 26.9 what? What is magnitude here? Magnitude back from before was this up here. And what are the units? Miles per hour, because these were velocities. So if you think about it as a word problem, he was traveling 25 miles per hour. He got pushed by the boat, so you can see it pushed him a little bit faster. All right, that's one part. We're done with the magnitude. Let's do the direction. Okay, to find the direction, let's go over here. Direction was the tan inverse, right? So theta, the direction angle, should be the tan inverse of b over a, or the y over x, of this vector. So 10 over 25. Okay, if I just put that into my calculator right away, I should get, in degree mode, let's see, almost got it, tan inverse, I get about 21.8 degrees. But remember with direction questions, we have to think about our quadrant, a little star for quadrant. Is that the right quadrant? Let's see, on our original vector over here that we got as our actual resultant, what quadrant would 25, 10 be? If you actually graphed it, he would be in quadrant 1. Well, when we did tan inverse, what quadrant did we get it in? We also got it in quadrant 1, so we know it's the right answer. So for example 6, the question is asking for what's the resultant velocity, the magnitude and direction of the boat after it's been pushed by the river. Your final answer is, it is now going 26.9 miles per hour at a direction of 21.8 degrees. You don't have to use any sort of direction in terms of south or north or east or west. You can just use the angle, and that assumes that you are in the first quadrant. And that's the answer to question 6.